Assalamu alaikum wa rahmatullahi wa barakatuh. This is Nazar Ibrahim and your mathematics instructor. And today we will be discussing the topic statistics, right? 0580 Mathematics Paper 2. And as you all know, this channel TB teaching by SM. We are making these videos. One of the intention is that the revenue generated for the first 6 months will be donated to Palestinian people, as we all know that they are suffering, so we should help them out. So our intention is this. So I would request all the viewers to kindly support our cause. Jazakallahu khairan. So question number 17. 10 athletes compete in both the 100-meter race and the triple jump. The results are shown in the scatter diagram. We have a scatter diagram over here. Okay, one of these athletes jumps 15.12 in the triple jump. So write down his time for the 100-meter race. So 15.12 means this 15, this 15.1, and this 15.2, right? And it is saying 15.12. It means that this is 15.1, this is 15.15, right? This is 15.14, and this will be 15.12. And in this we have this data, and we will be making up a horizontal line towards y-axis to check that which data is this. And this is between 12.8 and 12.9, the fourth square, right, which is lying over here, right? 15.1, sorry, lying over here, I'm sorry, right? So this is 12.8, this is 12.9, so this will be 12.88. Okay, so this is 12.88. Question number 17, part B. The values for two other athletes are shown in the table. On the scatter diagram, plot these points. So first, we will see 14.74 distance in the triple jump. So 14.74 means this is 14.7, this is 14.8, this will be 14.74, right? And in this 13.2, so you'll be going vertically, right? Sorry. So 14.74 and 13.2, right? 13.2 means 13 and 13.2 means 13.1 and 13.2, right? 14.74 and 13.2. Clear? Second point is 15.2, 12.76. So 15.2 lies over here, and 12.76 means 15.2 going vertically towards 12.7, 12.72, 12.76. Okay, so these were the 2 points which are plotted. On the scatter diagram, draw a line of best fit. So using the scale over here, and we'll be seeing how much maximum points can be used in the drawing of in the line of best fit. Okay, so this is no. If I draw this up, okay, no. So here we can see that the data is very much dispersed, right? So we have to look for the maximum number of points, and okay, no. Yes, this is the place where the 3 points are meeting, and that is the most suitable way, right? And the angle over here is 130. Wait a minute, 133, right? So I put the angle 133 so that the scale set over there. Yes, right? So this is the only line in which we are getting 3 points joined together, right? Other than that, there are no more than 3 points joining together. So using this 1, 2 and 3, you see this line, this line 2, this line 2, this is the only line where we are getting 3 points. No other line exists which are getting, in which we are getting more than 3 points. So this is the line of best fit drawn. Okay, so moving forward, what type of correlation is shown in the diagram? Since we can see that the line is like this, so this is negative correlation. Okay, question number 19. I think there's a number mistake. Okay, Ms. Salman gives a class 2 mathematics test. Okay, write down the highest mark. The scatter diagram is showing this about the marks each student scored. Write down the highest marks scored on test 1. Highest mark we can see on test 1 is the data 70, and we'll see that if any person, any student has scored 70, no, the highest data over here is this part. And this is, if I go horizontally, straight over here, so this is this line, right? This part. This is after 63 squares, and the last one 70, so it means 62, so 66. So 66 is the highest marks scored on test 1. Write down the type of correlation shown in the scatter diagram. You can see over here the data is like this, right? This. So this is positive correlation shown in the scatter diagram. Draw a line of best fit on the scatter diagram. Now here we have a lot of data, so you have to see that how many points can be joined in maximum. This line is almost taking almost 4 points, and if I join this line is also almost joining 1, 2, 3, 4, right? And this line, if we see, is joining almost 5 points. So this is the most suitable line where I'm getting 5 points, I guess. But but if I choose this line, which is over here, there are many points which are lying in this region. If I select this point, this line, as my scattered line of best fit, this line, so there's a lot of data lying over here. So this is not a line of best fit. We have to see that almost equal data lies between both the regions above and below the line of best fit. So I will choose such a line which is in between. So that is this line, approximately 1, 2, 1, 2, 3, almost. If I choose this one, this is also getting 4 points. This is much better. So selecting this line would be more appropriate, right? If I select this line, let me have a guess. Let's check. 1, 2, 3, and almost 4 points, right? Yes, and if I join together this part with this, so almost 5 points. So 1, 2, 3, 4, 5 points. And right, on the right there are a lot of data, on the left there's a lot of data, so almost equal amount of data values on the right and left as well. So this is the line of best fit. Clear? Okay, now Hamish scored a mark of 40 on test 1. He was absent for test 2. Use your line of best fit to find an estimate for his mark on test 2. Mark 40 on test 1, it means I have to draw check over here on 40. That is this part, right? So this is lying over here. If I make this here, this is almost near to okay, right? So this is 40, 42, 44, 42, 44, 46, 48, and almost 40, near to 50, so we can say 49.8, I guess, right? So we can round it off to 50. That will be much suitable, right? Because marks are between 40, we can be written as 49.5, can be at 50. 49.8 is not a good value for marks, right? So 49, oh sorry, 50. Clear? Okay. Question number 20. We have gamma records the times in seconds taken for a group of children and a group of adults to complete a puzzle. Box and whisker plot is showing this information. Okay. Find the interquartile range of the times taken for the children to complete the puzzle. So when we are doing interquartile range, that is upper quartile minus lower quartile, and this is indicated by upper quartile is indicated by this line. Sorry, this is upper quartile, and this is lower quartile. So value over here is, this is 60, between 60 and 80, that is 70, and this is this will be between is 50, so this will be 48. So 70 minus 48 is equals to 22. Clear? 22 seconds. The table shows some information about time in seconds taken for the adults to complete the puzzle. On the grid above, draw the box and whisker plot for the results. Okay, we have to draw the box and whisker plot. So in box and whisker plot, I have to make find out the upper and lower quartile. I have to know the minimum, maximum. So all is given to me in this data over here, right? So minimum, for minimum, this is the minimum line. So I have to make this minimum, they make this maximum. Minimum is on 28. So this is 30, this is 28. Okay. Making through a scale is much better, right? So this is 30, this is 28. Okay. Right. Since they have used 6 squares, so it is better if we use 6 squares only. Okay. 28, right? 28, 6 squares. This is 30, 28. One, two, three, four, 6. Okay. And lower and upper quartile and median. Lower quartile is on 42. So on 42, we will be making another line. That is this part. This is 42. And we have median 58, which will be this line. So using this line, that is this part. Okay. 1, 2, 3, 4, 5, 6. Okay. Median is done. Upper quartile is 70. So it means this part. And maximum is 75, right? So this will be in between 70 and 80, right? That is this part. This 74, this it will be 75, right? Okay. So now just completing this diagram. So joining these two parts for the middle part, right? And joining this part for the upper part for the box and whisker plot. Okay. The zoom way will be zooming in will be a better way of drawing the diagram here, so that it should be a better explanation, right? In between this, that is 1, 2, 3, 4, 5, 6, that is, draw a line over here and draw a line over here. So this is the box and whisker plot over here. So I can mention the data over here as well. This was 28. Just to explain, we will not be writing in the paper. I'm just drawing for the understanding of the viewers, right? There's 42 and median is 58. There's 70 and this is 75. Clear? Okay. Just to make understand, now I'm erasing it. Okay. Right? Okay. Going forward, this is done. The table shows the amount of money $X given to a charity by each of 60 people, and calculate an estimate of the mean. We are given the data in which frequency and amount in ranges are given, right? So estimation of mean in this case, when we are having a range of values, is the formula is summation fx upon summation f. Summation fx means sum, right? Now we don't have the data x in this form, we have it in range form. So we will first take out the x by using midpoint, right? So midpoint data over here will be 20 plus 0 20, 20 divided by 2 is 10, 25 plus 20 is 45, 45 upon 2 is 22.5. Similarly 25 plus 35 is 60 and 60 divided by 2 is 30. 50 plus 35 is 85 and 85 divided by 2 is 42.5. Similarly 50 and 100 are 150, summation of both, and dividing by 2 is 75, right? Is it clear? So we will be adding both up, adding all. This is 175. Okay, and frequency is known to me over here, right? Now multiplying this, how? Multiply f by x. It means 10 multiplied by its frequency, that is 21, plus 16 multiplied by 22.5 plus 30 multiplied by 6 its frequency, plus 42.5 multiplied by 10 its frequency, plus and 75 multiplied by 7 its frequency, but divided by total frequency, and total frequency is how many people? 60 people, right? Okay, now putting the values, 21 by 10 is 210, plus 30 by 6 is 180, plus we have 42.5 multiplied by 10 is 425. Okay, 16 by 22.5 is 360, and 75 by 7 is 525, divided by 60, right? So adding all, 210 plus 360 plus 180 plus 425 plus 525, 1700 divided by 60, 1700 divided by 60, 700 divided by 60 is 28.33. So the mean is 28.33. Clear? Moving towards question number 22. The table shows the results of 4 more runs. Okay, Aisha records the distance she runs and her average speed. The results are shown in the scatter diagram. We have this scatter diagram shown over here in the figure. The table shows the results of 4 more runs. Okay, on the scatter diagram, plot these points. 4.2, 13.4. So 4.2 will be between 4 and 5. 5 squares are there, so 1 is equals to 0.2. So 4.2 and 13.4 will be on vertical 13, and again 1 square is equals to 0.2. So 13.4 is over here. Then we have 5.7, 11.8. This is 5.6, 5.7. 11.8 will be moving towards, this is 11, and 11.8 will be over here. Then we have 7.1, 9.8. So 7.1 and 9.8, 7.1 is lying over here, and 9.8 moving vertically. This will be 9.8. Then we have 8.8, 8.3. So 8.8 is over here, and 8.3 on top is 8, and 8.3 is over here, right? I hope that's clear. Now all the points are plotted. What type of correlation? You know this is the negative correlation, right? Okay, on the scatter diagram, draw a line of best fit. So using scale to make the maximum, to make a line in which maximum points can be used. Okay, so over here we can see that there are less points, 3. Okay, if I'm using this is having 4, right? And this we have 4 points, right? Almost 4 points, right? And above 4 points is a lot of values, 7 values almost lying above this region. So we have to think of that as well. Selection criteria is based on this as well. So we can see around 2, 4, 6 and 7 values, and below is 3 values. Okay, if I go towards another line, we set another line, that is this portion. No, we have 3 values almost. If I join this, we are having 3 values again. So I think that's the more appropriate over here. That is this will be a line of best fit. So it is making on 137 angle. So I'll set this angle according so that the line remains straight, right? Okay. So making a line from here using scale, we have around this part, right? Almost meaning 4 points. Clear? Okay. So use a line of best fit to estimate her average speed when she runs a distance of 6 kilometer over here. So 6 kilometer means using the scale again. Six kilometer means this 6 kilometer. Okay, and using black now so that it's very broad. This is the value, and to match it with the x-axis, we have it over here. Okay, so this is the value over here, that is 10.8. okay, 4 squares, 1 square 0.2, so this is 10.8. Clear? Okay, question number 23. We have the table shows information about the times t seconds taken by each of 100 students to solve a puzzle. We are given again the similar type of a question, estimate of the mean time. Following the same pattern, we have to take out first midpoints, which I am marking over here, that is x. 10 plus 0, 10, 10 upon 2 is 5. 15 plus 10, 25, 25 upon 2 is 12.5. 20 plus 15, 35, 35 upon 2 is 17.5. 40 plus 20, 60, 60 divided by 2 is 30. For 75 plus 40 is 115, and 115 upon 2 is 57.5. Is it clear? Okay, calculate the estimate. So again, following the same formula, summation fx upon summation f. Here again, I'm repeating the summation means the sum of the product of fx, and summation f means the sum of all the frequencies. So 5 into 9 plus 12.5 into 18, this is f, this is x, plus 17.5 multiplied by 22, okay, plus 30 multiplied by 30, and plus 57.5 multiplied by 21, and divided by 100 students, because 100 is a frequency, right? We have been given in the question. The next is multiply this. 5 into 9 is 45. 30 into 30 is 900. 12.5 multiplied by 18 is 225. 17.5 into 22 is 385. And 57.5 multiplied by 11 is 57.5 multiplied by 21. Okay, it's 1207.5. Divide by 100. So adding this, 45 plus 225 plus 385 plus 900 plus 1207.5. That is 2762.5 upon 100. So dividing by 100, just do decimals back, 27.625. Clear? Okay, Emmanuel draws a histogram to show this information. The table shows the heights in centimeter of some of the bars. For this histogram, complete the table. So for histogram, the height is calculated through the formula frequency distribution is equals to frequency upon class width. So here height is frequency distribution, that is 3.6. and frequency frequency is, we are, I guess, yes, given on the top, right? So frequency is 9 and class width is 10 minus 0, which is 10. So 9 upon 10 is 0.9, which is basically, if I see 4 times, if I multiply this, I'll get 3.6. So it means the factor through which I have to calculate the remaining two heights is 4, right? I have to use the formula over here, that is this given, that I just wrote, and then I have to multiply the answer by 4 to get the height of the bar. Is it clear? Okay, so I'm erasing this. Okay, so frequency density is equals to, I have frequency over here for this is 30 and class width over here is for 20, the class width is 20 and between 40 and 20, that is 20. So it is 30 upon 20, which is equals to 1.5 multiplied by 4 is equals to 6. So the answer over here for this case is 6. Okay, so to calculate this, I have again the formula same, and frequency for this region is 21 and class width is 75 minus 40, which is 35, right? So 21 upon 35 is 0.6 multiplied by 4 is equals to 2.4. I hope that's clear to everyone, right? Okay, question number 18, it came now. Write down, we have been given data, the time t minutes it takes each of 50 students to travel to school is recorded. The table shows the results that on the model class. So the most repeated over here is, I guess, 19, right? So the model class is this 10 and 15. On the grid, complete the histogram to show the information in the table. For completion of the histogram, I need to draw the figures, and for drawing that I need frequency density. I have frequency, I have class width, I'll be taking out frequency density. But to draw, I should first check that the height of this given first data block, how it is calculated through frequency density. So frequency density is equals to, frequency is 7 and the over here is 10 minus 0, class width. So it is 10, 7 upon 10 is 0.7. So as I can see, the data over here is 0.7. So it means I just need to use the formula and calculate the frequency density for all the three model classes, right? All three range of data given. So frequency density for the second is, I have 19 and 15 minus 10 is 5. So 19 upon 5 will give me the height for the second one, 19 divided by 5, which is 3.8. Okay, second is 16 upon 20 minus 15, again 5. 16 upon 5, which is 3.2. Okay, third is frequency is 8 and frequency density 40 minus 20 is 20. 8 divided by 20, which is 0.4. Okay, I got the heights of all three. Okay, now 10 to 15, 10 to 15, the height over here is 3.8, right? For 10 to 15, this is for 15 to 20 and this is for 20 to 40. So height is 3.8, right? 10 to 15. So using a scale to find out 3.8, I guess. Okay, so 10 to 15 is 3.8, which will be lying over here, 3.8, right? Okay, then we have second is from 15 to 20 is, I have 3.2. So I will be making 3.2 over here. 3.2 will lie over here. Okay, then we have 0.4 from 20 to 40. 20 to 40, 0.4, which is lying over here. It's over here. Okay, clear? So that was all about the histogram making. I hope that's clear to everyone. Okay, moving to question number 24. We have the stem and leaf diagram given over here, showing the number of hours that each of the 16 students studies last week. Find the median. For calculating median, I should know the data, it is odd or even. So we have around 16 students, so definitely it is an even number data. So n upon 2 plus n plus 2 upon 2, n upon 2 plus n plus 2 upon 2, using this formula to calculate the values for which I will be summing and dividing by 2 to get the median, right? So n upon 2 means 16 upon 2, that is 8th, and 16 plus 2, 18 upon 2, that is 9th, divided by 2. So 8th data is 1, 2, 3, 4, 5, 6, 7, 8. 8 is this, 9 is this. And the key is 1, 2 represents 12 hours. So it means that 2, 7 means 27, and 2, 9 means 29 upon 2. So 27 plus 29 divided by 2. 56. 56 divided by 2 is 28. So median is 28. Mode is the most repeated data, and the most repeated data over here is, I can see 1, 1. Other than that, there's no repetition. So 21. Range is maximum minus minimum. So maximum is 47 and minimum is 12. So 47 minus 12, which is equals to 35. Clear? Okay, question number 25. Emma has 15 mathematics questions to complete. The stem and leaf diagram is given in minutes. It takes hours to complete each question. Okay, complete the table. We have mode, the most repetitive data, which is over here is, I guess, 16, 16, 16. Okay, 7, 7, 8, 8, 2, 2, no, 6, 6, 6, 3. So 16 hours. Most repetitive is 16. And we have around 15 values. So for median, we will be, for odd, we have formula n plus 1 upon 2. So 15 plus 1 upon 2, that is 16 upon 2, that is 8. 8th value is 3, 4, 5, 6, 7, and 8. That is 11. 11 minutes. Using the key over here, I found this. Range is maximum minus minimum. So maximum is 20 and minimum is 3. So 20 minus 3, which is equals to 17 minutes. Clear? Question number 26. Herrick draws a scatter diagram. Put a ring around one correct statement about this scatter diagram. It shows no correlation. It is not possible to tell if there is correlation as there are not enough points. It shows negative. It shows positive. Since to check a negative positive, we should have enough points, and since there are just 3 points, we can say that it is not possible to tell if there is correlation as there are not enough points. This is the correct option. Clear? Each of the 4 scatter diagrams shows the same set of data. A line has been drawn on each diagram. Complete the statement regarding this 4 diagrams. The line in diagram dash is the most appropriate. You can see that here this is not an appropriate diagram. We can see that here there are no meeting points. That this is incorrect, this is incorrect. Now if we see the remaining diagram A and diagram C, we should note down that in diagram A the line of best fit is just touching a single point, and in diagram C it is just touching almost 1, 2, 3 points. So diagram C is the most appropriate line of best fit. Okay, question number 27. We have again a stem and leaf diagram. 22 people data given in this. Find the mode. The most repetitive over here is 6, 6, no, 2, 2, 2, yes, okay, 1, 1, 1, 9, 9, 6, 6. So most repetitive is 2, 2, 2, and the key is 1, 1 represents 11 items, so 2, 2 means 22 items. Median, 22 people, again n upon 2 plus n plus 2, 2 upon 2 upon 2. So to take out the values which we have to take, this is the formula, and then summing and then dividing by 2. So n upon 2 means 22 upon 2, that is 11th, and 22 plus 2, 24 upon 2, that is 12th upon 2, right? So 11th data is over here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is 29 and 31 is 12th. 29 plus 31 upon 2, that is 31 plus 29 is 60, and 60 upon 2 is 30. Clear? The table shows the relative frequency of the games won by a football team. The number of games lost is twice the number of games drawn. Here we have to take out the two values lost and drawn, and the statement which the question is saying that the number of games lost is twice the number of games drawn. So it means that number of games lost, over here we can say number of games lost is equals to twice of number of games drawn. That is, if I say this x, so this will be twice of x, right? Is it clear? If I name it as if I name it this x, so it will be 2x, right? So number of games lost is x or 2x. Tricky, right? So number of games lost is twice the number of games drawn. So I multiply by 2 the number of games drawn, I will get the number of games lost. So I can say that this should be written like, wait a minute, this should be written like this. This is 2x over here, right? Lost is 2x and drawn is x. Clear? This is the correct way of describing, because the number of games lost is double the number of games drawn. Clear? Okay, now just solving this. So 0.1, because we know the relative frequency when we are discussing, we know that it is related to probability and it is always equal to 1. So 0.1 plus 2x plus x is equals to 1. So 2x plus x is 3x, 1 minus 0.1 is 0.9. So x is equals to 0.9 upon 3. If I divide 0.9 by 3, I will be getting 0.3. So this will be 0.3, and 0.3 into 2, which is twice the number of the lost of the drawn games, is 0.6. I hope that's clear. Okay, question number 29. We are having a stem and leaf diagram again. Shows age in years of each of 15 women. Complete these statements. Here the model age is the most repeated, that is 1, 5, 8, 9, 1, 1. And the most is 1, 1, I guess 2, 3, 5, 6, 9, 0, 2, 3. No repeated data except this. So 41. If I say 3, 1 means 31 years, so 4, 1 means 41. Median age, since 15 women, so odd data, and that is n plus 1 upon 2th value. So 15 plus 1 16, and 16 upon 2 is 8th value. So 8th value is 1, 2, 3, 4, 5, 6, 7, 8, 43. The percentage of women that are older than 51 years is older than 51. How many people are older than how many women are older than 51 years in this question? We have 50, 52, 53, 58. 3 are the women which are older than 51 years, and the total are 15. So taking out percentage, multiplying by 100. So 3 upon 15 means 3 ones are 3, 3 5s are 15, and 5 ones are 5, 5 2s are 10, and 0, 20%. So 20%. Clear? Okay, question number 30. Thibault records the number of cars of each color in a car park. He draws a pie chart to show this information. Calculate the sector angle for the rect cars. So the calculation for the sector angle formula is The component for which we are calculating this rectangle is kept in the numerator, that is 3 for the red cars, and the total cars, that is 8, 5, 13, 13 plus 4, 17, 17 plus 3, 20, is kept in the denominator, and the total angle of the circle for which the portion is to be calculated is 360. So 0, 0 cancels, 2 ones are 2, and 2 18s are 36, 18 threes are 54 degrees because it's angle. I hope that's clear to all of the people. Inshallah, you'll enjoy this, you'll understand it. I would request again all the viewers to kindly support our cause, like our channel, and promote this so that we can get a better revenue and that can be donated to Palestinian people. Jazakumullahu khaira. Assalamu alaikum wa rahmatullahi wa barakatuh.